Hello everyone, we are back with another Leetcode problem, Pascal triangle 2. Last time we solved Pascal triangle, so where we understand about the Pascal triangle, how it will look, and the problem was that we have to return the first n rows of Pascal triangle. And this is the Pascal triangle 2 problem, where this is they have given n integer n, and we have to return the nth row of Pascal triangle. Basically, if this is the Pascal triangle, we have to return the last row of Pascal triangle only. And the one important thing is that they are following the zeroth index. Let's try to understand this problem first. So if this is my Pascal triangle, the first and last element will be always 1, and the remaining element will be sum of about 2. So they were looking for the answer, the last element, the last row. Okay, so if n equal 5, the output will be 1 comma 4 comma 6 comma 4 comma 1. Okay, so to do this, we have three different way to solve this problem. So let's look at the three different approach. First approach is using the array, which is the same approach which we have solved the Pascal triangle first problem. The time complexity to solve this problem is O of n square, and the space complexity is O of n square. Second approach is DP, and third approach is mathematics approach. And in the second approach, which is related to DP, we actually optimize the space complexity from O of n square to O of n. And in the third approach, which is mathematics, we actually also optimize the time complexity to O of n. Okay, so let's first look at the first approach, which is array. So it's the same approach how we solve the Pascal triangle 1. Only changes which will come here is that we will, instead of returning answer, we will return answer of -1, because we only need the last row of our triangle. Okay, second changes we will do here is that for I in the range of for I in the range of nums, instead of nums we will do nums plus 1. Okay, why we will do that? Because we are following here the zeroth index. Okay, that's why. Now let's look at the, and this code will work perfectly fine. Okay, I can also show you. So we will basically row of index +1 and -1, and the rest code will remain exactly same. Now let's look at the second approach, which is DP approach. So DP is dynamic programming approach, and we will look, we will solve lots of problems from the DP moving forward. But let's try to solve this problem. Okay, so in the DP problem, what we will do, we will create a DP basically. Okay, so the DP will look something like this. So we will create a DP of n cross n. Okay, n cross n, which is 5 cross 5 here. Okay, and if you see here, so we will try to change this Pascal triangle into a matrix. Okay, triangle to matrix. We know last time we have looked at the index of these element. So this was 0 comma 0, this is 1 comma 0, 1 comma 1, 2 comma 0, 2 comma 1, and 2 comma 2. So even if we know, like here also we have 0 1 2 3 4, 0 1 2 3 4. If we map all these elements, we will get 1 here, 1 here, 1 1 here, 1 1 1 1 as the last element. This will be 2, this will be 3 3, this will be 4 6 4. Okay, so basically we will try to return the last rows basically in the DP. But how DP work actually, it will actually break your problem into a smaller steps. So first we will assume that this is our base case. Okay, then we will create the first row. Okay, so this will be first row, and using this base array, then we will create the third array, then we will create fourth row, and similarly. So this will be our base case, and subsequently we will create the our scenarios. Okay, so you can see, this element is basically sum of about two element. This will be sum of this, and this will be sum of this and this. Okay, so basically what we will do, we will say that, hey, a of I comma j will be equals to a of I minus 1 j plus a of I minus 1 and j minus 1. Okay, so this is how we will solve this problem. And for that, what we will do, but like we can solve this problem, we can give a whole DP as a space, but then it will be O of n square in the time complexity and O of n square in the space complexity. But we told that we will solve into O of n. So for that, what we will do, we don't need the whole matrix. We can have two rows, simple. Okay, so what we will do, we will create two list. Okay, let's say this is my DP. Okay, DP preview and DP. Okay, so yeah, so this is my DP preview and this is my DP. Okay, initially both will be 1 1 1 1, every element will be 1 1 1 1. Okay, and moving forward, what I will do, I will apply so whatever steps I will apply my I will solve my base scenario case on the basis of starting from this index, which is 1, to the ith index. Okay, and this ith index will be based on where we are on which steps are we following. Okay, so if I want to show you here, so we will always start our scenario from on this line and we will apply it to this. Okay, because we know the rest of the elements are 1 1 only, so we just want to calculate these elements. Okay, yep, these elements. If I highlight, we just want to calculate these elements. So what we will do, we will say that the DP. So basically we will apply that the DP of ij will be DP of I minus 1 j and DP of I minus 1 j minus 1. And after that, what we will do, we will exchange over DP DP with, sorry, yeah, we will say that my DP comma DP preview will be equals to DP preview comma DP. So now what will happen, my DP preview will become, so let's suppose at this position I have determined that this will be 2. Okay, using this, right? So this will be 2, and I will calculate, I will say this steps. So my DP will update, my DP will become DP preview. Okay, and my DP preview will become DP. Okay, so DP preview will become DP. Okay, so what will happen after this point basically? So after this, it will look something like this. So it will be 2 row only. Okay, so the above one will be DP preview and the second one will be DP, and it will look something like that. 1 2 1 1 1, and this will be 1 1 1 1 1 1. And now we are solving this array. So we will say, or we will start from here, we will end till here. So this will be sum of this and this, so that will be 3, and this will be sum of this above element, that will be 3. And then I will again update my DP as a DP preview and DP preview as a DP. Okay, and so yeah, let's look at the code. So this is how we will solve this problem. We will create our DP preview and DP. So it will be a 2D, it will be something like that. So this will be DP preview and this will be DP. Okay, and then I will have, basically, if I want to show you, initially it will look something like this. Okay, the above one is DP preview, the below one is DP. Okay, the row. Now what I will say, I will apply R in the range of 1. So we will always start my problem from this position. Okay, and I will end on the basis of C. So as I move forward, my C will going to be updated. So at this position it will be this. Then when I move ahead, the second steps, okay, so C will start, it will start from here and it will end here. Okay, and then I will update basically my DPC as DP preview C minus 1 and DPC, and DP DPC minus 1 as equals to, I will exchange it basically, and then I will return the DP preview. Now let's look at the third solution. Okay, so third solution is basically a mathematical approach where we are actually also optimizing the time complexity. So what we will do, we will here create answer. Okay, and it will contain 1 1 1 1. If n equals to 4, then it will be something like that. Okay, then if I able to write once again, if it's 1 1 2 1 2 1, Pascal triangle 6 4 1. Okay, now let's write one more time, one more line. Okay, I want to show you. This will be 1 5 10 10 5 1. Okay, so if I want to solve this thing, right, this one, so this will be 0th index, 0 1 2 3 4 5, right, and similarly this will be 0 1 2 3 4 5 6. So what will happen, so this end point, I will say that this is actually 4C1, that is 4. This element will be 4C2, that is 6. This element will again go to 4C3, which is 4. This element will be 5C2, which is 5 multiplied by 4 factorial, 3 factorial, 2 factorial. So it will be 3 factorial, it will go 10. So the Pascal triangle are actually a combination, okay, permutation combination it actually uses. So each and every element is actually n c. If these are the ith, okay, and these are the jth, if I say, then I C J. this will be the each element. Okay, I hope you're able to get it. But if we solve these, uh, I ICJ. So our main problem here to solve ICJ. Okay. But like it will be let's make it NCR simple. Okay, ICJ. So it will be n factorial upon n minus r factorial upon r factorial, which is n minus 1, n minus 2, and so on, and n minus r factorial, r factorial. So somewhere here n minus r factorial will come, and both will cancel out. So it will be n minus 1, n minus 2, so on. Okay, n minus r plus 1. Okay, and below r minus 1, r minus 2 till 1. Okay, so we have to solve this basically, okay, for each and every element, but then it will take lots of time complexity. So how we will solve? So this is also a kind of a base problem, and then we will move ahead. So what we will do, let's suppose there is in mathematics, we will say that if you know NCR, then calculating NCR plus 1 is easy task. What? Let's look at this. So this is NCR, you got it right. Now NCR plus 1 will be n factorial n minus r minus 1 factorial r plus 1 factorial. Okay, so this will be n minus 1 till n minus r minus 1 factorial upon n minus r minus 1 factorial r plus 1 r factorial. Okay, so yeah, we can do one extra thing here basically. Instead of this, we will say this is n factorial only, and this will be here basically it will be this will be n minus r upon n minus r minus 1 factorial. And if we divide both of these two, okay, this equation and this equation, then we will get NCR upon NCR plus 1 will equals to n factorial. N factorial will cut down. Okay, and r here r factorial will be there, so r factorial will also cut down. So and n minus r factorial will also cut down. Okay, so what we will get basically, we will get that r plus 1 comes at the top, and below there will be n minus r. Okay, so this we will get. Okay, and if we try to solve NCR plus 1, that will be equals to n minus r upon r plus 1 NCR. So this you will get after solving everything. Okay, so what we have done in the code actually, so our main objective is to create a loop where n is a constant, right? So n minus r will update and r plus 1. So we have to solve, what. So once we have NCR plus 1, then we can calculate NCR plus 2. So what we have done, we have created our answer, which will initial will be 1 1 1 everywhere. Okay, and I have up, so up will be on the top part, which is initially I keep it as n. Okay, and down, which is initially I keep it as a 1. Okay, now what I have to do to achieve this, I have to keep on minusing r. Okay, so from here I have to make r as minus, and here I have to keep on adding. Okay, so what I will do, so that's what I am doing here. Answer of I will be equals to answer of I minus 1 Okay, so here what I'm saying, let me take you this. So here I'm saying that my NCR plus 1 is equals to NCR is equals to NCR minus 1 upon some x comma y. Okay, up comma down, and then up, in the up I will take minus 1, and in the down I will take plus 1, and I will keep solving it, and at the end I will return answer. So this is how we can solve this problem. I know it's very mathematical, but yeah, there is one another solution. So I hope I able to explain you all three approach. First is array approach, where we use the Pascal triangle problem only, and we make simple two modification, and we able to solve it. But the time complexity was O of n square and space complexity was O of n square. Then we look at the DP approach, where we created the two array, DP and DP preview, and we cannot save the time complexity, but we can save over space. So that's why we have created only two DP, and we have base case, and we have to solve over one particular problem at a time. And yeah, and then we look at the math problem. We first understand the how the numbers are coming from which combination, and how we will keep on solving NCR plus 1 as equals to NCR, and how we take the denominator and up and down values, and how we update it. So yeah, I hope I able to explain to you this problem. This is very important problem. So yeah, we will meet next time. Bye bye.